Hello everyone. Unfortunately, I had a death in my family and I'm not going to be able to be here today or on Thursday. However, you're still carrying on as if I was there and you're still doing the lessons. What you're going to do today is I'm going to have the video for you and you are going to go through the slides. You'll get that packet from the substitute. At the end, you'll have classwork problems. You're going to complete those. He or she has the answers for them, so you will be able to check your answers. You will also complete the homework packet. The next set of problems that is due, it was originally due for today, but we didn't get to it, so you're going to have them due Thursday. And Eric, you're going to stamp them. If Eric's not there, Rosemary, someone else, you guys can do the homework check. So that's going to be due next class. You're also still going to have a quiz on this next class. So make sure that you do the classwork, check your answers, do the homework. If you finish the classwork early, you can get started on the homework, and then you don't have to worry about it. Don't lose anything because you can use it for the chapter test. And yes, you will have a quiz next class on this. So if you have any questions, you can send me a question on Edmodo. I'll be able to answer it for you. Hopefully someone else in the class can help answer the questions for you. The substitute will keep track of your behavior and let me know if anyone should not be earning a stamp today or Thursday. Remember to keep all those materials so you can use it for the test. Please be respectful. I love you and I miss you. The parallel circuits. What happens to the current in the circuit to the right? So if you remember, series circuits, there was just one pathway that is followed. Parallel is when it splits like this, and it can either go this way or it can go this way. So remember, these are those Christmas lights where if one bulb goes out, it's okay because you still have other ones. So it has other paths to go. So what happens to the current in the circuit to the right? The sum of the currents through each of the resistors in a parallel circuit equals the current of the battery. So if you remember, in series, you added the voltage and you added the resistance, and that gave you the total. In the parallel, you add the current. So the current's not equal the entire time. So the important thing that you want to write down here is this equation. The total current is both of them added together. So now, what happens to the voltage? Well, the voltage stays the same. So in circuits, the current stayed, in series, the current stayed the same. In parallel, the voltage stays the same. So they switch places. So make sure you write this down, and make sure you write this down. And now, since I'm not there to explain all of this, the equation that you're going to remember for the resistors, if you remember in series, the resistors just added together. Here, the resistors add this way. It looks confusing right now, however, we're going to do it in a second and you'll see exactly what that means. So, what is the equivalent resistance in the circuit? So we see that R1 equals 3 ohms and R2 equals 6 ohms. So now we want to get both of them added together. So if you looked at the previous slide, it said 1 over Req equals 1 over R1 plus 1 over R2. So we're going to plug in our givens. Got 1 over 3 plus 1 over 6. And remember, in order to add fractions, they need to have a common denominator. So 3 and 6 both go into 6. And in order for 3 to become 6, you multiply by 2. And the same thing on the top. So now we get that the equation is 1 times 2 is 2 over 6 plus 1 over 6. Which gives us 3 over 6. So now if you notice, it's 1 over the R equivalent. And if you remember from when we did optics, when we were solving for something in the denominator, what we did was we did the reciprocal of the fraction, so we flipped it over here, and then we divided. So now we've got that the equivalent resistance is going to equal 6 divided by 3, which equals 2 ohms. So if you need to, you can pause, rewind, and replay this slide over. This is the hardest part of the whole thing with parallel. So the first step, remember, was to plug them into the equation, find a common denominator so that you can add them. Then we're going to do the reciprocal and then just divide. So what is the voltage at any spot in the circuit? Well, we just said in parallel circuits, voltage stays the same the whole time. The total voltage, remember we said equals V1, equals V2, etc. So at any spot in the circuit, the voltage is going to be 18 volts because that's what they're giving us as the total. Question says, what is the current through R1? So in the previous problem, we said that V equals 18 volts everywhere. And now we see that R1 equals 3 ohms. So if we use our equation, I equals V over R, we can do I equals, our V was 18, and our R was 3, and we get that our current equals 6 amps. So now it says, what is the current through R2? Well, again, our V is 18 everywhere, and now our R2 is 6. So we do I equals V over R, and since we're talking about at R2, we're going to use the R2 value. So our V was 18, and now we're going to divide by 6, and our I is going to equal 3 amps. So now what is the power used by R1? Well, we already said that at R1, our I was 6 amps, and our V is 18 volts. So power equals I times V, which is going to be 6 times 18. And our answer for that comes out to be 108 watts. So now what's the power used by R2? So at R2 we said our I was 3 amps. Our volts are 18. So now power equals I times V, which means we've got 3 times 18. So our power is going to equal 54 watts. All right, so that is the end of your slide packet. So if you need to rewind anything and review it, you can. If not, you can work on the classwork problems and check your answers with the substitutes. And you can also do your homework problems. Remember, you're having a quiz on this next class. Okay, be good.